Hi, this is Mr. Manley. In this video, we are going to finish our three-part series on transformations. This third video is non-rigid transformations. Non-rigid. So the basic idea is that if I had a function that looks like, say this, it's a parabola, and if I took another function, or if I transformed it into something like this, I've given it a vertical shrink. It has gotten vertically lower. And then if I took and went to a function like that, then it's vertically stretched. Additionally, I could also refer to this horizontally. So I could say that this first one here, I could refer to it as a horizontal stretch. It's gotten wider. And this second one, I could say, has a horizontal shrink. It's gotten thinner. And depending upon our notation, we're going to talk horizontally or vertically. The first notation that we have here is going to be vertical. So this 2f of x right here, that is a vertical transformation. And if you go back to our function notation where we said, well, if the function is undefined and we write something like that, then that is going to be a way of saying that we're talking about a shift, a vertical shift, right? And then if we write it like this, we're going to say we're talking about a horizontal shift. Now here, writing it like this, we're going to be talking about a vertical stretch or shrink. And I'll just, looking ahead to the next one, we might as well take it now, that if I have it written like this, then that's going to be a horizontal stretch or shrink. And we're starting off here with the vertical. This vertical, so this one is matching this notation. And what this 2 means is that all my y values are going to be doubled. Y values are doubled. And can you imagine, then let's just take this, if I had 1/2 f of x, then all y values would be cut in half. So when we have the number here, the number's here, the c is here. So when we have the number here, it's vertical, and vertical corresponds with the change in y value. So that's what you have to keep straight. So take that note down and make the note to yourself, however you need to make it. That's what we're going for here. So we're going to just take this one that is given in this problem, and it's saying given this f of x, so that's this random undefined function here, that's our f of x. Given that f of x, we want to draw 2f of x. And 2f of x is a doubling of all of the y values. So I've got this point here at 0, 0. If I double the y value, what do I have? I have 0. So it's the same point. Now if I take a point out here, if I take this point, say here, and that's at point 2, negative 1. And if I double the y value, what am I going to have? I'm going to have 2, negative 2. So that's going to be my new point. If I take this point out here, and I want to be sure I didn't draw over the specific location here, right? So it was back here. So if I take that point right there, that point is at 4, negative 2. So what do I have to do? I have to double the y value. So I'm going to be at 4, negative 4. Right? This one over here to the left is down at negative 4. I have to double the y value. So the y value was at negative 4. I've got to double it down to negative 8. And then up here and there. And that's it. That's 2f of x. All of the y values have been doubled. Okay, let's go ahead and look at the other case, f of c of x. All right, so here I've got f of 2x, and this is going to go. Remember when we do f of x plus c, and I say if c is positive, then it's left, and if c is negative, it's right. And that's the opposite of what you think it might be. The same thing is at work here. So for this one, I've got the value there, which means I'm going to change my x value. So it's going to, how did I refer to that over here? I said CF of x is a vertical stretch shrink, and I said the y values were doubled, okay? So here, I'm going to say that f of cx, let's just remind ourselves, f of cx is a horizontal stretch or shrink. And then this 2 here, it's not going to double the x values, which is maybe what you think, because it's 2x and you think, oh, 2x is being doubled. But it's going to, I'm going to do half of the x values. And then likewise, I talked about over here, I talked about, all right, so 1/2 f of x, that's doing half of the y values, back when we were doing the vertical non-rigid transformation. So in this case, look at that again. All right, in this case, I want to stay consistent here. In this case, I've got f of 1/2 x. So what's that going to do? That is going to double. This would double my x values. Okay, so actually doing what is given here, this is going to take this random undefined function over here, which is f of x, and to graph f of 2x, I'm going to double all the x values. So again, like here at the origin, I've got 0, 0. If I double the x value, I still have 0. So, I mean, I'm not doubling the x. Did I say, I skipped back there. Did I say double the x values? I may have, but I meant half the x value. So we're doing half the x value. So 0, 0. So half of 0 is 0. So nothing changes with that point. And then I take this point up here, and that is at negative 4, 4. And all I'm going to do for f of 2x is I'm going to do half of the x value. So I'm going to do like that point there. And that's all I need. You just have that point, connect those dots. And that is f2 of x, f of 2x. So that is non-rigid transformation, a couple of applications of non-rigid transformation. And then we have this third that is combining a couple of things. So let's just take a look at this problem. In this problem, it's saying for each coefficient, choose whether it is positive or negative. So the coefficient, this A is referring to this A. This B is referring to this B. So positive, you probably know this without even learning transformations. You know if a parabola is up, it's positive, as in A and B, and if a parabola opens down, it's negative. And now you know that there's a connection between that and the overall discussion of transformation. And then the next question here is choose the coefficient that is closest to 0. Well, all of these are of this form. They're all a transformation of x squared of this form, c f of x. So the one that is closest to 0 is the one that is going to be the smallest, or it's the one that's going to shrink the function down the most. Does that make sense? Like if I go 1/2 f of x, that's shrinking the function down. If I go 1/5 f of x, that's shrinking the function down even more. So that's what's going to get me close to 0, is which one shrinks the function the most. All I should need to do on that is look at the graph and find out where so normally with f of x equals x squared, so if I have f of x equals x squared, one of the points that I have on that is 0.11. So I just want to look at what is happening when x is 1 and what is the y value. So for this one here, I've got 0.1, and that's 1, 2, 3, 4. It looks like 0.14 approximately. For this one, it looks like I have 0.1, and then maybe I go up to 1/3. For this one, I've got 0.1, and then it's going down to -2. I don't care about the negative. I just care about the absolute value. I care about the 2 units, not the -2, but the 2 units. And then this one looks like I have 0.1, -1/2. So which one is the closest to 0? Clearly 1/3, right? 1/3 is closer to 0 than -1/2. So that's going to be, what was that? B would be my response to that. And then choose the coefficient with the least value. All right, and in this case, I do want to pay attention to the sign. So when I was choosing closest to 0, I didn't care about the sign positive or negative. But with this one, I do want to pay attention to the sign and the least value. If I look at these y values here, 4, 1/3, -2, -1/2, the lowest value is the -2. So that's my selection for that is going to be C. And that concludes our discussion of transformations, and probably a good look at just about any transformation problem that you will see.